Hi to you all. I'm Emmanuel Lebose, and I'm handling this course together with my colleague Frederick Kenneth Appiah. I'm here once again with a presentation on our fourth chapter that deals basically with the technical design of wind systems. Now, in our presentation, we would go through wind turbine design considerations. We will go through electrical grid. We would explain some wind turbine electronics. We would talk about how the control systems of wind turbines, how they operate and work. Then we finally look at some wind farm design considerations. Wind turbine design considerations, first point. Now, in designing a wind turbine, a lot of things we have to consider, some of which are the aerodynamic efficiency. They have to do with efficiency in converting the power within the wind to rotational movement of the turbine blades. And this has to be done as efficiently as possible. Much energy will have to be captured, from the wind as much as possible. But bear in mind that there's a limit to which there's a limit to energy that a wind turbine can actually capture from the wind. That's the best limit. And then the second point, reliability. The system also has to be very reliable because wind systems are designed to actually last a minimum of about 20 years. So whatever plants you are designing should be able to stand, the test of time, the weather and all that, the harsh realities of the environment, for this stipulated time. So it has to be as reliable as possible. The cost also would have to be engineered. The components have to be engineered so as to minimize the cost involved in the acquiring of the components, because minimal cost actually helps to bring down the final cost of producing electricity. Then we also have aesthetics. It has to be appealing to eyes. It has to be nice. And then the number of blades. This is a decision the designer has to make. So either 1 blade, 2, 3, 4, 5 blades, or even 10 blades. That one is a decision the designer makes. But you need to bear in mind that the higher the number of blades that you go for, you create more inertia for the turbine. More inertia also means it makes it difficult for the turbine to begin rotation, or makes it difficult for the turbine to respond to fluctuations, in the wind this thing. It makes them heavier also. So you have more stress imposed on the tower and all that. So all those things are things you need to look at, in order to optimize the parameters. So we move on to electrical grid. The electrical grid is the infrastructure that basically, deals with the production of the power and then conveying this power to the point where it will be utilized. So you have the main wind turbine producing this power, the electrical connections or the grid or the transmission lines that would carry this particular power to the demand centers. And within this transmission lines or this network, you have also transformers, to change voltages for the specific parts of the network, for final delivery also. Now move on to wind turbine electronics. The wind turbine, when you open up the nacelle, a typical wind turbine, of which most of you have seen in one of the diagrams in earlier lectures, what you realize is that you have a generator inside a wind turbine, that converts the rotary motion of the blades into electricity, of which, is what we are interested in, the electricity, of course. And then we have wind turbines, using either AC or DC, generators, but most of the large wind turbines, normally use this AC generators, and the DC generators is actually used among very small wind turbines, 50 kilowatts and all that, very small ones for household use and all that. So you need to bear in mind that these AC generators don't generate AC, readily. So if it's used to an AC load, there's no need for any inversion. But for a DC, if it's to be used for an AC load, then the DC will have to be converted to AC. So we move on to the control systems of the wind turbines. The control systems help the wind turbine systems to actually make decisions, about optimizing power production from the wind turbine. And a typical wind turbine control system has three main components. That's sensors, to measure the process variables. It has actuators to manipulate the energy capture and component loading. Then you have control algorithms to coordinate the actuators based on information gathered by the sensors. So basically, what these control algorithms do is that they are the heart, of the whole decision-making process, of these particular control systems. Let me cite a typical example. Let's assume that a wind turbine has is taking power from wind blowing from the north. Now, when the direction of the wind changes to the east, what happens is that the wind vane, on the wind turbine senses that there's a difference in direction, and then sends this input into the control systems. Then the control system also activates other mechanisms to change the direction of the wind turbine towards the east. So the same thing happens if the direction changes from the east to the west. Signal is sent to the control system by the wind vane. The direction has changed to the west. Then actuators or certain mechanisms are activated to actually change the direction of the turbine towards the west. So it's a typical example of how the control systems work. Now we'll go to wind farm design considerations. When building a wind farm, several other things would have to be considered. Some of which include, the different phases, within which the project will be realized. First, you have planning and preparation phase, Then after you're done with all the activities relating to this particular phase, you move on to the development phase. Then after the development phase, you move on to the engineering phase. Then after engineering phase, you move on to the construction and installation phase. Then finally, operating and maintenance phase, where the activities within the operation and maintenance is actually carried out throughout the time of the plant's life. So we have planning and preparations phase. In this phase, consultations with local authorities are done. Your proposals are sent to them. That you want to build a wind farm, so and so, and all that. All concerns, are addressed at this particular stage, and then you want to also talk to the people within the community. You have dialogue between them. Whatever their concerns are, you educate them to the benefits and all that, and then you also address all their concerns. So that they will give some positive indication that really this thing has to come here into our community. And then after these first two steps are accomplished, then you move on to feasibility studies, where you go to the site, inspect the land size and all that. You do some site investigation. You look at the topographical features of the site, so it will involve some surveying also, looking at the site and all that. Then after that, you go through wind resource assessment, where wind speed data is taken. Wind speed data and wind speed direction, or wind speed data and wind direction data are taken for analysis. So from the wind speed data, that's when you realize that whether it's financially, it will make financial sense to actually go in ahead and invest in the project or not. And then you have environmental assessment, where you carry out some analysis on how the wind farm is going to have impact on the environment, the community and the surrounding environment. Then you go to detailed cost estimates. You look at the cost involved, in doing all this feasibility, and then building the actual plan, the cost of the wind turbines and all that, So all these things are done in the planning and preparatory phase. So after you're done with that, you move on to the development phase, where basically you negotiate for power purchasing agreements, and this is especially for private developers who are coming to generate the power and sell to probably the utility or something. And then you also acquire permits, approvals, you get much more legal, environmental approvals, the land use, building permits, and operating agreements generally and all that. You get all these approvals at the development phase. Then you move on, to the very important phase, the engineering phase, where most of the things to be done, are actually designed. And so here, some rigorous or detailed analysis of the wind speed data is done in combination with the topographical information of the sites, so you can know exactly at which points, will be the best places to actually place the wind turbines. Then the wind flow regime over the whole terrain also is analyzed, and then the wind turbine performance, if the wind turbine is placed there in a particular wind regime, how much power is it going to generate and all that. So all these analyses are done at this stage, the sound levels, how much noise to be produced, are the noise too much or is it within acceptable levels and all that. You need to determine all those things at the engineering phase. And then you also design the turbine foundations, the electrical network, and then access roads, the roads that will carry most of the construction equipment, to the sites. So all these things are done at the engineering phase, and then after you have done with the engineering phase, you move on to the construction and installation phase, where most of the things that have been designed are actually constructed physically. So the turbine foundations are constructed, the access roads are constructed, electrical network is also built. The wind turbines is also assembled and installed at this particular stage. And we move on to operations and maintenance phase. You need to bear in mind that this phase actually lasts through the whole duration of the project. Because it's something that you'll be doing repetitively. The typical life of a typical wind farm is a minimum of about 20 years. So within this whole time frame of 20 years, most of the activities within operation and maintenance would have to be done repeatedly. Annually, weekly, monthly, depends on activity. So in this particular phase, maintenance is done, repairs are also done when there are breakdowns. The performance of the wind turbines are also monitored, and analyzed, and this is very important, to serve as input to future decisions for improvement of the wind turbine systems. And then environmental surveys are also conducted at this stage to verify, or ascertain that the environmental impact of the wind farm, doesn't go beyond acceptable levels, and then training programs are also organized for employees of the plant and all that, especially where there's a need for special skills, to perform certain specific duties and all that. So all these activities are done within the operations and maintenance phase. And then this brings us to the end of the fourth chapter. Thank you all for your attention, and we will definitely meet again with the subsequent ones. Thank you.